आवाज येतोय का यश?
हो येतोय सर.
येतोय ना?
हो हो.
ओके. अनम्यूट ठेवलंय तुम्हाला. आज क्वेश्चन विचारणार आहे मी मध्ये मध्ये. दिसते का स्क्रीन? अजिंक्य बेलसरे. अनम्यूट करून सांग मला. स्क्रीन दिसतीये का? अजिंक्य कुठे गेला? अजिंक्य चैतन्य स्क्रीन दिसतीये?
येस सर.
ठीक आहे, सुरू करायचं.
येस सर.
Yesterday, 2-3 students given me message, sir, please take a quick revision of previous part also. So for this chapter only, I'm going to take a fast revision of this ionic equilibria, very fast revision. So for the examination point of view, whatever the important part, I will tell you only. This will be important for exam. And the remaining parts we have to read at your home because it is not important for the. Yes, who is disturbing? Mute yourself. Otherwise, I have to compulsory mute all. So for the discussion purpose, I purposefully made you unmute today. So we will take a quick revision. This is the introduction part. It is a deleted actually for this year. So no any question will be asked on this introduction, remember. Then types of electrolytes, 1 marks or 2 marks question can be asked on it. But the possibility is very, very less. What is mean by electrolyte? What is mean by strong electrolyte? What is mean by weak electrolyte? These concepts are very easy concept. If the question it is asked for the examination, it will be for only 1 mark. Remember. So this is a basic knowledge, what is mean by electrolytes. So without understanding the electrolyte concept, we can't understand the hydrolysis and dissociation concepts. Then degree of dissociation is very important. 100% questions will be there on this degree of dissociation. They can ask the definition purpose, they can ask the numerical purpose, but no any long question will be asked on it. Degree of dissociation, the question will be for 1 mark or only 2 marks. Then I am coming to the theories of acids and bases, RNAs theory, 2 marks question. If the question it is asked, it will be asked for 2 marks. Explain RNAs theory of acids and bases. We have to write the definition of acid and we have to write the definition of base. And if the example is given, it is well and good. If it is not written, then no issue. If the question is for 2 marks, if the question is asked like this, define acid according to the Arrhenius theory, only we have to write the definition. Don't write example. If the question is for 2 marks, explain Arrhenius theory of acids and bases, then we have to write the definition also and example also. But only the definition having the weightage. If the example is written, then it will be more clear cut, what you can say, clear cut view of the definition, so the examiner can understand. If the definition is wrong and if the explanation or if the example is correct, then also he will give the full marks. So for the explanation purpose, we have to write the definition also and write the example also. Then I'm coming to this Laurie-Bronsted theory. Again, this question will be asked for 2 marks, same like Arrhenius theory. They can ask what is meant by acid, what is meant by base, what is meant by conjugate acid. Remember this conjugate acid base pair, and also prepare a chart of this theories. I have given this chart. What is meant by acid, what is meant by base according to the Arrhenius theory, according to the Laurie-Bronsted theory, according to the Lewis theory. So by remembering this chart, we can write all the definitions of acids and bases. And also for the orals of the final board exam, they can also ask these questions. What is meant by acid according to Arrhenius theory? H2SO4 is acid or base? Yes, कोण कोण नवीन मुले आहेत? Apurti, tell me. Apurti is there? Apurti, unmute yourself and give me the answer. What is meant by acid according to the Arrhenius theory? Unmute होत नाही का? एक मिनिट. Apurti. Yes. Suresh is there. Suresh Satralkar, 186.
Yes, sir.
Tell me what is meant by acid according to the Arrhenius theory.
Sir, any substance which releases H plus ions in water solution.
Very nice. Raj Nandini Joshi is there. 178. Raj Nandini Joshi, I think she is a new student, came from A division. Raj Nandini, unmute yourself. Rajvardhan, 197. Rajvardhan, unmute yourself and tell me, ammonia is acid or base? If it is acid, according to which theory it is acid? If it is base, according to which theory it is base? Tell me. Or if anyone, he can or she can unmute and give me the answer. Yes, anyone? Because this is a most important part in this chapter, acids and bases. If these concepts are clear, then we will discuss the next part. Roshan Yadav, 193. Roshan. Chaitanya.
Yes, sir.
Tell me ammonia is acid or base, or if it is acid, according to which theory it is acid, if it is base, according to which theory it is base.
Sir, it is acid.
Ammonia.
No, sorry. Base. It is a base.
Why? Yes, if anyone can know the answer, he can tell me or she can tell me. Ammonia is acid or base? If it is acid, why it is acid? If it is base, why it is base? According to which theory it is acid or base? Tell me. No one? Sarthak, 132. Avdut. Avdut Pokre. Hitesh, tell me. 157.
Sir, it is base.
Yes.
Sir, it is base.
Who is telling me the answer? Yes. Rajvardhan,
Sir,
tell me.
ammonia is a base
Why?
because it is by Lewis theory.
By which theory? Lewis theory.
Lewis theory.
Yes,
No,
yes, correct.
Lewis theory.
Correct. It is also called as Lewis theory. It is also called as Lewis theory because in case of ammonia, this nitrogen having the lone pair of electrons. So according to the Lewis theory, if this lone pair of electron is given to any substances, it is called as base. Remember, this is a very, very important question. This is also included in chapter number 13, amines. So remember the answer, amines are always basic in nature because of lone pair of electrons, and this lone pair electron, if it is given, it is called as base. And what is meant by acids according to the Lewis theory? Anyone?
So the substance accepts an electron pair.
It is already, the screen is in front of you. All the answers are written here. So we have to remember this chart only. We can give the answers of any questions. Now the simple question I want to ask, NaOH is acid or base?
Base.
According to which theory? According to which theory?
Arrhenius.
Very good, very good. Now,
Arrhenius.
very good. According to the Arrhenius theory, the substances which gives which having hydroxyl group and which gives OH minus ions in aqueous solution, it is called as base. I want to ask one question. CH3COOH, acetic acid. Already it is acid, but according to which theory it is acid? Tell me. Acetic acid, CH3COOH.
Lewis.
Wrong.
Arrhenius.
Yes, because it is
Sir,
having
Arrhenius
hydrogen.
theory.
Because it is having hydrogen, remember. If hydrogen is there in aqueous solution, it will produce the H plus ion concentration. So it will be acid according to the Arrhenius theory, remember. Amphoteric nature of water, rarely the question can be asked on it. So this is for your knowledge purpose only. 99% no any question will be asked on this amphoteric nature of water. Then no any question will be asked on it also. Ionization of acids and bases, only you should know how the strong acids ionize, how the weak acids ionize, how the weak bases ionize. So always remember, strong acid and strong bases, they completely dissociated, and they completely form the, if HCl, as an example, HCl is taken, HCl is completely dissociated as H plus and Cl minus ions. But If you take this example of weak acid and weak base, two examples are given here. See, the acetic acid, it is a weak acid. If it is dissolved in water, it will be partially dissociated. Double-headed arrow, this double-headed arrow indicates it is partially dissociated. And what is the meaning of this double-headed arrow? This indicates the equilibrium between ions and unionized molecules. Remember, that's why this is double-headed arrow. It is shown. It is not completely dissociated. So the examples can be asked for 1 mark. Write the examples of strong acids and strong bases. What is meant by weak acids and weak bases. No any larger question will be asked on it. This will be not asked for the examination. You know about this K and KB. According to the law of mass action, K is the dissociation constant of weak acid, and KB, this is a dissociation constant of weak base. Yes, this is very, very important. Ostwald dilution law is very, very important. Write 2-3 times. Make a practice. This is very easy. Initially, 1 mole of acid is present and volume is V dm cube. At equilibrium, fraction of it will be dissociated. So remember this chart. By remembering this chart, we can derive this equation. So amount present at equilibrium will be 1 minus alpha. Then at equilibrium, it will be alpha, and this is the concentration in moles per dm cube. So this is for weak acid, weak base. Both the equations or both the these derivations are very, very important. So the numericals are important on Ostwald dilution law. So we already discussed about these numericals. No any numerical, it will be asked same to same. So remember this note, the very important note, no any numerical in the entire textbook, it will be asked as it is. So the values will be changed, remember. Means the type of the numerical will be same. See, we will take one example. A weak monobasic acid, for example, here 12% is taken. Instead of this 12%, they can change the values 15% or 20%. This concentration can be changed 0. Instead of this 0.05 molar, they can give the different concentration like 0.07 or 0.06. Only the values will be changed, remember. But the formula it is same, the process is same, the method is same. Only the values will be different. And whatever the numericals which are given in the textbook, solved numericals, same type of numericals will be asked. Type of numericals will be same. So don't take tension about the numericals. This autoionization of water, this can be asked for the derivation purpose. Remember, autoionization of water means pure water ionizes. It is in very small content. In pure water, the concentration of this H3O plus and the concentration of OH minus is same. It is exactly equal to 1.0 into 10 raised to minus 7. Remember, this is called as ionic product of water. So ionic product of water is what? Kw. Kw is ionic product of water, and this is defined as, by using this equation we can define, this is the product of molar concentration of hydronium ion and molar concentration of OH minus. By remembering this equation, we can define the ionic product of water. And if you know the ionic product of water, we can derive this equation pH plus POH is equal to 14. So before this pH and POH, this relation is very important. This can be asked for 2 marks for the board examination. Derive the relation between pH and POH for 2 marks. It is very important. Then they can ask the definition of pH. They can ask the definition of POH for 1 mark. So in section A, there is a possibility of these questions. What is mean by pH? What is mean by pOH? Write the example of strong acid, write the examples of weak acid. What is mean by strong electrolyte? What is mean by weak electrolyte? What is mean by electrolyte? Such questions, easy questions are expected in section A. This is a non-evaluative part for this year, so no any questions will be asked on this neutral solution, acidic solution, and basic solution. But the numericals will be asked for the examination. So today we will start this part, hydrolysis of salt. Hydrolysis, this word already you learned many times from the 8th standard, 9th standard, 10th standard, also in 11th standard. Hydrolysis means addition of water. So hydrolysis of salts, you know already about these salts. There are 4 different types of salts. You know, already students know one type of salt. This is a common salt is NaCl. But other than NaCl, there are many salts. There are 4 types of salts. We will discuss one by one. First one is salt of strong acid and strong base. So this salt is prepared by using strong acid and strong base. For example, NaCl, this is a common table salt. This is prepared with a salt. This salt is prepared with strong acid and strong base, NaOH and HCl. And this is a Na2SO4. This is NaNO3, KCl, KNO3. All these salts are prepared with strong acid and strong base. Then second type of salts are salts derived from strong acids and weak base. Means strong acidity is used and weak base is used. For example, NH4Cl. This is example of salt of strong acid weak base, CuSO4. NH4NO3, CuCl2. Then weak acids and strong base. Acid is weak, base is strong. CH3CONA. So we can easily understand the weak acid is acetic acid and the strong base is NaOH. KCN, in which one is weak acid and one is strong base. Then strong base can be NaCN, Na2CO3. This is also example of weak acid and strong base. Then last part is both are weak. Acid is also weak and the base is also weak. So these are the salts prepared from weak acids and weak bases. CH3CO, NH4, NH4CN. So today we have to prepare this chart and we have to paste where in your study room you have to paste this chart, because this is very important for the board examination. Types of salts. So these are the some examples. Examples can be asked for the examination. So first, what is mean by hydrolysis concept? We will learn about this hydrolysis concept. So make a concentration. Concept of hydrolysis we will discuss. So concentrate carefully. When a salt is dissociated in water, see, when a salt is dissociated in water, it dissociates completely into its constituent ions. Remember, when any salt is dissociated in water, it dissociates completely into its constituent ions, cations, positively charged cations and negatively charged anions are there. But the solvent water dissociates slightly. You know, already in ionic product of water, we learned about this. Pure water dissociates very small extent. This dissociation is shown again. This is H2O. If it is dissolved in water, it will be dissociates very small amount. Partially it will be dissociated and we get this one is H3O plus hydronium ion and OH minus ions. Pure water is neutral. Pure water is neutral because the concentration of this H3O plus and the concentration of OH minus is same. Already we know about this concept. In pure water, the concentration of this H3O plus and the concentration of OH minus is same, and it is exactly equal to 1 into 10 raised to minus 7. In ionic product of water, I will show. Yes, see this slide. So the concentration of this H3O plus and the concentration of OH minus, it is exactly same, and it is given here 1.0 into 10 raised to minus 7. See, this is a concentration of OH minus and concentration of H3O plus. This is about the pure water. Then if the ions of salt do not interact with water, see, means if the salt is dissolved in water and the anions or cations prepared by the salt, if the ions, these ions may be positively charged or may be negatively charged, that's why ions word is used here. If the ions of the salt do not interact with water, if the ions do not interact with water, then what will happen? The concentration remains same. The concentration of hydronium ion and the concentration of hydroxyl ion, it will be remains same, or it will be remains equal. And that's why the solution is neutral. When this is possible, when the ions do not interact with water, this will be possible. And the second condition or second possibility is what? When one or more salt ions reacts with water. Now the concentration of the H3O plus and concentration of OH minus will be disturbed. If the ions of the salt do not react, then the concentration will be same. Then the solution will be neutral. But when the ions react with water, they reacts with water means when they reacts with H3O plus or OH minus ions, then what will happen? The concentration of this H3O plus and the concentration, this concentration will be disturbed. So the solution become acidic, basic or neutral depending upon the nature of salt. Remember, this concentration of H3O plus and concentration of OH minus, it will be same when the ions do not interact or when the ions do not react. But when the one or more ions will react with water, the equality concentration of the H3O plus and OH minus will be disturbed. The solution does not becomes neutral, it becomes acidic or it becomes basic or it becomes neutral. It will be not neutral, because when the ions react, it will be turns into acidic or it will be turns into basic. Never it will be neutral. When it will be neutral, when the ions do not react, then the solution will be neutral. But when it reacts, it will be converted into acidic or it will be converted into basic. This will depend upon the type of salt. So acidic solution or basic solution, it is depend upon the nature of salt, remember. So the reaction between ions of a salt and ions of a water, it is called as hydrolysis of salt. It is very easy concept. So hydrolysis means nothing but reaction between ions of water. You know what are the ions of water? It is H3O plus and OH minus. So the reaction between ions of water and the reaction between ions of salt, it is called as hydrolysis of salt. So the definition is given here. In your own words, we can write the definition. The same definition which is above definition, it is written below. Hydrolysis of salt is defined as the reaction between cations or anions. Directly we can use this word ions. So the reaction between ions of salt and the reaction between ions of water to produce acidity or basicity, or sometimes even neutrality. Remember, but in what you can say, not always neutrality, but exceptional, in exceptional cases, neutrality, the solution becomes neutral, but many times it will be acidic or it will be basic. So this definition can be asked for the examination point of view. Remember, they will not ask this derivation, but they can ask, define the concept of hydrolysis. So hydrolysis is very easy concept. It is the reaction between ions of water and ions of salt. Then we will discuss these hydrolysis of first type, salt of strong acid and salt of strong base. If you understand this salt, then the next types automatically we will understand. First, so concentrate carefully. NaCl, you know, this is a very commonly used salt. NaCl, sodium chloride salt. This salt is prepared with strong acid. This is a salt of strong acid and strong base. So strong acid by using HCl and strong base NaOH. By using this strong acid and strong base, this NaCl salt is prepared. So when this salt is dissolved in water, what will happen? It will be dissociates completely into its ions. So NaCl aqueous, the meaning of aqueous, when it is dissolved in water, it produces ions, Na plus aqueous and Cl minus aqueous. Completely it is dissociated. It is shown with single-headed arrow. See, this single-headed arrow indicates completely it is dissociated into Na plus and Cl minus anions, and Na plus cations are prepared. So this Na plus and Cl minus ions have no tendency to react with water. This sentence or this word is very, very important. If the ions of salt do not react with water, then what will happen? The concentration of the OH minus and the concentration of H3O plus will be not disturbed. It will be remain same. So the solutions becomes neutral. Remember, solution becomes neutral because if this ions Na plus, once again I'm showing this, Na plus and Cl minus having no tendency to react with water, because its reason is given. This is because the possible products are given when this NaCl it is react with water. The possible products are NaOH and HCl. These are the NaOH and HCl of such reactions are strong electrolytes. Again, these are the strong electrolytes, and they dissociates completely. So the dissociation, it is given here. The dissociation of NaCl with water, it gives HCl and NaOH. So it is again strong acid, it is strong base. Again, they are dissociated. So HCl plus NaOH plus H2O. So this is a dissociated as H3O plus ions are prepared, Cl minus ions are prepared, Na plus ions are prepared, and OH minus ions are prepared. So these are the products and these are the reactants. See, Na plus, Cl minus, OH minus, H3O plus. These are the reactants and these are the products. Thus, the reactants and the products are same. We can see this is the reactants and this is the products are also same. This suggests that, or this implies that neither cation or anion of the salt reacts with water. See, they only ionizes, they do not react with water. That's why the concentration of H3O plus and the concentration of OH minus, it will be not disturbed. If it is not disturbed, the solution is neutral. Hence, it may be concluded that the salt of strong acid and strong base does not undergo hydrolysis. Now my question is for all the students, anyone can give me the answer. Why the solution of strong acid, salt of strong acid and strong base is neutral? Yes, anyone tell me? Yes, anyone can tell me the answer why the salt of strong acid and strong base is neutral? In single line, tell me, in one sentence. The answer is very easy. Manav Jori is there? Yes, Manav Jori is there. 131. Unmute yourself and tell me. Manav.
Yes, sir.
Yes, tell me the answer. Why the salt of strong acid and strong base is neutral? Why the solution, sorry, solution of strong acid and strong base. What is the reason behind that?
Because it dissociate completely and form H2O.
No. No, anyone? The reason is very simple. It is written here also. The equality is not disturbed. Why the equality is not disturbed? Because the ions formed by the strong salt of strong acid, they do not react with the ions of water. It is simple. So the solution is neutral. If the cations or anions formed by the salt, they react with the ions of water, then the solution becomes acidic or basic. But when the ions means there are two types of ions. One is cation and one is anion. When the anions or cations do not react with ions of water, then the solution is neutral. And same it is happening in case of this NaCl. When this NaCl it is dissolved in water, this Na plus and Cl minus, they do not react with water. See, we can see here. We can see this Na plus, Cl minus, and this ions, and again these are the same. Only the ions are formed. They do not react actually. So this is the reason why the solution of NaCl is neutral. Such type of question can be asked for the exam. This is application based question, remember. Why the salt of strong acid and strong base does not undergo hydrolysis? What is the reason? Reason is that because the ions of salt does not react with ions of water. Only one line we have to write the answer. If the ions do not react, the solution becomes neutral. Means hydrolysis do not takes place, remember. Then I am coming to this salt of strong acid and weak base. Only 1 minute is remaining. I think it will be not completed, but I will try to complete it. CuSO4. This CuSO4, it is a salt of strong acid H2SO4 and weak base CuOH twice. It is a copper hydroxide. So this copper hydroxide and this strong acid H2SO4, when these are mixed together, this salt is prepared. Now, this is a different salt than the NaCl. NaCl is a salt of strong acid and strong base. But CuSO4, it is a salt of strong acid and weak base, remember. This is a weak base. When this copper sulfate, it is dissolved in water, it dissociates completely. Its dissociation is given here. CuSO4 aqueous, it produces this Cu2 plus and SO4 2 minus ions. But this shows